Alright, another draft physics video presentation. Alright, so I misread JPG guy's comment, where he was saying marbles answer the questions. It's the old answers that are just complete evasions that I think I've actually already read in a video, but I might go back to them just to point out that it's just the same as pretty much Piro's answers, which is they're just evasions. Somehow I need more information. I can't understand the question, blah, 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 blah. Same thing AB Science did. You can't use the word thrust to describe throwing things from a spaceship. Yeah, you can. I mean, Professor Lewin did it. Fuck. Anyway, so I figure I'll read his comments because I didn't read all of them, and that way we'll see where I made my mistake in that sense. And we'll get to some other subjects raised by somebody else, and there'll be real physics for a change. But it's sort of redundant, and that's part of the problem. Is it's pretty hard to write titles that include all the content in every video, and I really don't want to make 10-minute videos on individual subjects. And it's it's ain't as easy as you think, JPG guy. But whatever. Alright, I watch your videos on a fairly consistent basis, and only recently, when you mentioned it, did I realize you had these questions in the description. Well, I've referenced that they're on the website. The website logo pops up in the beginning of the video, and they're right there on the website. Frankly, what every video, I'm going to make videos like DeHilster, and I'll spend the first half of the video just saying the same redundant crap that I've been saying for 4 years, and I'll just keep saying it over and over and over. I'll do a commercial in the videos. Yeah, I don't think I will. Maybe a good video title would be "Please answer the questions in the description." Well, we've tried this, been there and done that in the past in terms of trying to get people to respond to videos on the actual subject. But instead, they bring up other subjects on videos not on the subject. And so the discoherency isn't just my problem. It's a problem with people on the internet. So unless I take all the comments and move them somewhere, which I'm perfectly willing to do, is to put them on the website, if there was some sort of really useful exchange. Now, you think there's some useful exchanges that take place here in the comments section. I would say they're not useful because they're always premised on a bunch of bullshit, okay? And 80% of them are tainted by a bunch of interaction by troll accounts. And I don't see it as being very valuable, frankly. Anyway, what I've done is put the subject videos on the website, the three main subjects, gravity, energy, and light. They're on the website. They're short, less than 15 minutes or less. That's what I want to discuss. And no one will stay on those subjects, or at least not on those subjects in a rational context, in the sense that they wish to call me a deceiver and a liar because from every bit of everything I've ever been told, springs don't have a bias. They don't compress more for fast things and compress less for slow things. They don't care about how the energy is received. Now, maybe that's not true, and maybe all the physicists would, just never paid enough attention to find out the truth. But from my experience, it's true. So that needs to be discussed first, right? If we can't agree what a spring is, then we can't really discuss all the complex implications of the spring, can we? No. So until we resolve that question, there's no point in really having a whole conversation, is there? Not really. Okay. I think that would generate answers. What we need is evidence, and that's what's lacking. So I compiled what I could of evidence, in the sense that we have the Professor Lewin air track experiment that sort of demonstrates it doesn't matter what size mass is over here, this thing always does the same thing, on the two sides of the spring. And then the wooden block experiment, I sat there and, frame by frame went through it and showed that the velocity of this block, I changed this block from a 1 to a 2 to a 3 to a 4, and the velocity of this block always stays the same. So I've showed evidence They haven't shown is any counter evidence. And without evidence, the conversation is kind of empty, isn't it? Don't we have to argue the experiments? I mean, if they're going to be able to use this out, that, oh, I have a formula, okay? Yeah, it has no relevance to reality, but it's a formula I have. And again, do you want to argue math in a comment section? You've already seen how convoluted that can get, because the math isn't connected to the real geometry. So connected to the real geometry, and then it might mean something, right? You do have to have some picture somewhere. And the commenters don't do that. All right. I will attempt to pass these questions on to Piro and others. If you go to the Mindless Marbles channel, I just didn't read the whole comment. You will see he or she has one video posted. Yeah, he's posted the one video I have delisted of my videos just because I was completely wrong. I was stupid to make the video. And so he finds it necessary to highlight the video I've conceded was a mistake. So I'm going to find all of Mindless Marbles comments and put them on my website, I guess. Okay, I guess that's only fair play. All of his stupid, idiotic, all his comments are stupid. So I'll just put them all on display, I guess. Because that's what people with integrity do on the internet. Yeah. Anyway. So he wishes to represent me by a video I've pointed out was stupid. I made a mistake. So he thinks that's a good argument tactic. Okay. That's how you win the good fight. Yeah, okay. Anyway, if you go to you will see he or she has one video post. On that video, the first round questions you gave me months ago were posted. Yeah, and I think I said something like, why the fuck are you posting comments on that video? But anyway, I understand it. We can't just message people anymore. Mindless answered them. No, he didn't answer them. So he just asked for the clarifications, right? But asked for clarification. So he just evaded the questions. I mean, the implications of the questions are kind of obvious. The 10-ton versus 5-ton train thing is kind of obvious. The point is kinetic energy says one has more energy. Can that energy be collected? So if I put a generator on the wheel, will I actually generate more electricity from the faster train than the heavier train? And I think, I would think anybody logical would have to concede, gee, that seems problematic. Obviously the more massive train does have more momentum. I mean, not more than the lighter train, but I just mean in the traditional sense of momentum. It has all of this extra capacity. So yeah, it's going slow, but it's it's got a lot of Gatorade in the in the cabinet. Anyway. On your last video, you answered the comments and then deleted them on camera. Yes, because I don't find them relevant to the video. They're covered in troll slime. And I just don't think the conversations are productive. So I don't know what else to tell you. This bisection of subjects is just not useful. It's not coherent. It's not the right place for the conversation. All right. I wish the comments that discuss physics would be left up. So if you can find those, you mean discuss it in what context? Not discuss it in the context of my 15-minute video on the subject, but discuss it in some other context. And I'm saying I don't want to discuss it in some other context. I want to discuss it in the context of those videos. So find something on those videos that's wrong and then comment on that video explaining how it's wrong. And no one does that. And frankly, I'm just saying that's probably the way the comment's going to stay. Because it's not going to stay when it's not on the right video. As long as they don't contain personal information. Because it makes cross-examination possible within the confines of the comment section. It also just means it makes distraction and confusion possible. Because I respond in videos. It means I have to post a bunch of time codes for, here's my answer to this stupid question. Blah, blah, blah. It's just not very coherent. So I respond in video, they respond in comments. It just doesn't make for much of a back and forth in a comment section where the video actually isn't in the comment section. So again, I should put the transcript of my answer in the comments section. No, there's no continuity here. It's unfortunate that nobody makes physics videos, okay? Apparently nobody's able to do this talk about physics thing. Nobody's able to answer questions, interact, do video responses. There's no capacity to do it. Puro can't do it. Nobody can do it. It's not that complicated. You play somebody's video and you respond to it. What's so fucking difficult? But apparently no one can do it. No one but me. I'm apparently the only person capable of playing somebody's video and pointing out where it's wrong, or where I disagree, or why I disagree. So there's no continuity. And if we go to places that are just exclusively text, like Quora, well, does the conversation ever stay on the subject? No. Are the questions forced to be, 14 characters? Yes. Are you likely to get good answers? No. And then what do they want to talk about? They want to write math in the comment section. They want to discuss mathematics in the comment section. All right, anyway. On your comment video, you answered the comments but then deleted them on camera. I wish, okay. Because it makes cross-examination, so there isn't enough of that going on. So if you're going to tell me there's some good back and forth in the comment section, I'm going to tell you you're full of shit. Anyway, and again, it's just trolls, and I'm not going to give trolls more of a voice than they already have. And you have stated you want to cross-examine physics. Yeah, I don't want to cross-examine trolls. I want to cross-examine what does the evidence say. Let's examine the evidence. We don't even need to cross-examine it. Let's just examine the evidence. And what I'm saying clearly is there's absolutely no evidence of kinetic energy being a real thing. There's no physical evidence of it. Momentum does work. The universe would work just fine without anyone ever hearing the words kinetic energy or mv squared or 1/2 mv squared. All of that crap has been nothing but a distraction. All right, but back and forth is impossible once you delete the comments. So, yes, whatever. What I'm saying is you're saying back and forth is impossible. I'm saying I do video. I don't like commenting much. I don't think text is a brilliant way to argue these subjects. I think talking and drawing works really well. And playing clips of video experiments, I think that works very well. Okay? But I don't think commenting works really well. All right, and I'll demonstrate that by reading the other comment on this video and point out how, well, it's only 17 subjects in the one comment. Gee, that's not a problem, is it? Yeah. All right, on a recent video, you say you want a kind of follow the bouncing ball explanation of physics. I just used the term, okay? I want the explanation of physics to be coherent. That is, I don't want it to have overt contradiction in it. Okay, and I think there's overt contradictions, and the other part would be just completely wooey, vacuous, made-up crap. Okay, so clearly MV square started as completely made-up, vacuous crap, in the sense we now know it was 100% wrong. That is, it got answers that were 100% out of alignment. I mean, there were grotesquely wrong answers, and they were defended as if they were right answers, and everybody was very confident who was defending it. And the evidence supports it, and yet clearly the evidence couldn't have possibly supported it if we found out later that the right answer is 100% different. Right? Right. And nobody wants to talk about that terrible history. Nobody will even acknowledge the terrible history, let alone explain the terrible history. You've heard me ask the question, right? How do you account for this terrible history? Is this good science? Leibniz's arguments were well-based and well-founded arguments. Again, they won't even admit this isn't Newton's physics, that Newton never in his lifetime did he contemplate the universe with mv squared in it. Yet they claim this is somehow, classical. No, this isn't classical. This isn't Newton. This isn't Galileo. This isn't Descartes. It's not even Leibniz, for fuck's sake, because Leibniz was 100% wrong. Do they deal with these subjects? No. Do they evade them? Yes. Okay. Is that another way of saying the picture of physics isn't dependent on math? I'm saying math is just another way of saying something, right? So, I mean, how many times do I have to say this shit? You're saying you watch some of my videos. You haven't heard me say what math is? Math is a formalization, okay? That's why they call them formulas. It's a formalization. That is, you're taking the essence of it. You know, black tie, white jacket, blah, blah, blah. And you're saying these are the essential components of tuxedo, for example, or whatever. And so you're making it really simple and saying this is the simple diagram, okay? It's mass and velocity. Those are two components. And you can say, yeah, you really don't need to know anything else. You don't need, well, squishy might be important later, but who cares? You don't need, is it sticky? Is it this? Is it, no, mass and velocity. That's the real essence of it. And then you can move the object through your math, your formalization, your maze, okay, based on what the essential components are. Like if you were to say person or human, and you want to figure out mobility. Well, first you figure out, well, it's a biped, okay. It can use its hands, okay, if necessary, but they're usually just for balance. So, you say, well, it's like a cheetah. Is the tail important? Well, the tail's really important if the cheetah is going to be able to do all this little swervy shit. But it's not going to have anything to do with the speed generation. So it depends on what you want to analyze, what you need as one of the essential components, right? But I'm just saying, if you want to cut human beings down to what they are, then you just say, okay, it's a, whatever, 100 kilogram mass on two bipedal, feet that have a surface area of XYZ. And, so it's a formalization. It's a way of drawing it, okay? It's a way of recognizing or understanding its geometry. But again, that's what all the formulas are, right? They're just representations of physical geometry. When somebody says mv squared, the squared thing means that you have a length in two ways, and you have an area created by those two vectors. And so it's a description of the mass, the substance of the area. Okay, by squaring it, you can figure out how much area it covers. But it's not the physics. The physical universe isn't math. Okay, sometimes, physicists joke and they say something like, well, and then the universe does the math and figures out that this ball has to go this way and this one has to go that way. Well, obviously the universe doesn't do math, okay? It's actually doing the physical geometry. And so it doesn't need to do the math because it's actually physically doing what the math represents the essence of. So obviously, mathematical formulas, in my opinion, that are at all long are probably wrong because we kind of, I think, know that the fundamental universe is kind of Newtonian. It is kind of simple, okay? Opposite reaction kind of crap, it's doing something really simple. And so any of our formulas that get too elaborate are probably incomplete in the sense they haven't understood the real essence of it. They haven't figured out that whether the shirt is nylon or cotton doesn't matter. It's not gonna disqualify the tuxedo. All right. Well, anyway. Yeah. So long answer, short question. That's the other problem, right? Some comments can provoke a lengthy description to explain. I mean, if I have to explain what mathematics is, okay, yeah, it's going to take some time. Is there another way of saying a picture of physics that isn't dependent on math? So, of course, you can just draw the physical circumstance, and that's what I'm doing in all these videos, is drawing the physical circumstance, explaining what I believe and why I believe it. I think momentum is a real thing. It's something you're carrying, as I pointed out. It's a vector difference inside of you. If you're going that way, it's because inside of you, unrelated to the other things in your environment that you're going a different direction than, you have a bias in a different direction than they have a bias in. Your arrow this way and this way are two different sizes. Yeah, and that means That's why you're going in that direction, is because you contain your velocity. Your velocity is inside of you. The wrench flying through space is elementally different than the wrench sitting on Earth. The two wrenches have different elemental inside of their atoms. Their atoms are doing different things. That's why the wrench keeps moving and the wrench on Earth isn't. Okay. It really is, but it just is in a different direction. Anyway, that isn't dependent on math. Is that another way of saying a picture of physics that isn't dependent on math? So I'm saying math is, it can be useful, but if you want explicit, you want to get the answer, like how fast is it going or some other thing, sure, math is useful. But I'm just saying math isn't physics. The math is not the physics. Two-ness is a physical quality. Okay, we can understand that two-ness plus two-ness equals four-ness. Now there's four-nesses exist in these things because there's four of them. There's a four-ness in that area of space. Okay, so what can I say? Yes, that can be useful. But is the four-ness a quality of physics? Are you describing something that the physics knows, that somehow the universe knows this is four-ness and it knows this is two-ness? It doesn't need to know it. It's already doing it. All right, anyway. Because I think Feynman and others stated certain aspects were incomprehensible without math. So that's what you're saying, but I don't, I'm just saying I think that's just ludicrous. The math makes the physics incomprehensible in many cases. It works the other way around. And the math can be just rationalizations and contrivances, as I've accused. The 1/2 mv squared formalization, that is the mathematical crap, is a contrivance. They've broken something as simple as what work is to make that a rational equation. So they've turned Newton into the work equation and then used the work equation to make the kinetic energy theorem rational. And it's not made rational by another irrational statement. You could see it in the look, I showed Lewin doing the math, and he takes the momentum equation, which makes perfectly good sense in the real world, and then he combines it with the kinetic energy formula and creates a third equation that is bastard retarded. I mean, it's obviously the two equations are completely in contradiction with each other. The two equations can't both be correct. So you've overtly said, I'm going to add incorrectness to create a third equation. The third equation can't be correct if one of your first two, the two you mated, one of them isn't the same genetic code. Well, then you're not going to have a happy accident. You're going to create a monster. All right, anyway. So I went to Quora seeking clarification and found one answer that you might find interesting. I mean, just bullshit. So I'm sorry, I've already been there and done that so extensively. And there are no rational answers. I'll post it below. So this doesn't have anything really to see. He first should cite the question that was asked. But anyway, since not everybody in the population knows calculus, I'll try to demonstrate it using arithmetic. Let's assume you know force, mass equals acceleration. So we know that mass, it's not mass times acceleration. It's mass times your change in momentum. That's Newton's formula. Change in momentum over time, actually. So I just mean, so they're already cheating the truth because they invented this word acceleration, okay, to turn everything into a gravitational experiment, and everything isn't gravity. When the kinetic balls hit each other, there's no, well, the gravity is pushing against it at a constant rate. No, the object is flying through space at a constant rate, but it's not going to give its energy at a constant rate. The energy is just going to move through the two objects, through whatever connection they have. And the connection is going to be between electrons, if you understand physics at all. So the electrons in one object are going to push on the electrons of the other object. And it's not going to have anything to do with a constant reigning force. It's going to have to do with, there's going to be a lot of shit happening really fast. There's going to be a lot of matter interacting with a lot of matter very quickly. So anyway, so I mean, I'm not going to bother. This is the typical gravitational experiment. Okay, gravity is not impulse. We're talking about action and reaction in the impulse sense, that something's carrying just a confined amount of force. That is, a confined amount of movement relative to everything else in its environment. And the question is that is going to be defined as a force. That movement is a force against all the other stuff because it's doing something different than all the other stuff. And so what's the difference? We're just trying to qualify what's the difference. What does the difference add up to? And mv works. And mv squared doesn't work. And 1/2 mv squared also doesn't work. Shit. All right. So, so that's the end of the quote. It seems to me to be saying the formula isn't always exact. So again, the exactness of calculus is already a given. It's a simpler root, but you can never do calculus perfectly because you can't create infinitely small amounts of a sample. And you couldn't spend an infinite amount of time analyzing infinite samples. So obviously it's a generalization. It can't be an exact answer, but it can be way past good enough if you take enough samples. So if you want to sample my temperature, for example, my temperature might fluctuate. So you take a few samples here and here and here, and you get a general trend, and you can draw a pretty good line that is, this is your average temperature. That might be off by a few million degrees or something. Sub-degrees. Who cares? Okay, it's not enough to be critical. But again, that's all calculus is doing, is trying to take a volume that's, can be poorly shaped and tell you what the volume is. But it's really just saying, look, I have a shape that's really ugly. Well, if I turn it into a square that fits inside of all of the shape, and then I have another square that fits on the outside of the shape, I could make an approximation about the two difference, the space that is at issue. So I know a certain amount of it for sure, okay, and then the rest of it is the stuff that I have to create an approximation for. So I can cut it down. I can make my calculus easier if I first take a piece of the geometry and remove it. And then I'm just left with the parts that are hard to calculate. And then I make those into a bunch of little squares. That's all calculus is doing, is just saying how many bytes can I make. And, so you're just trying to count the beans, but some of the beans are misshapen. They're not the same size, so I can't just count the beans. I have to look at the bean and say, is the bean a half bean? Is it a quarter bean? Is it a 3/4 bean? That's why calculus is helpful. But I'm just saying, it's not some magic. It doesn't do anything magical. It's giving you a very simple answer. And if you were given just the square, you could just go, well, length times height, there's the volume. But you're not given a simple square. You're giving lines that are broken. And so that's why you need calculus, is in cases where things like in gravity, every second you're moving into the force, you're doing something where you're changing your position in the gravity and you're moving through the range. So you're trying to calculate two different things. So it's like the rocket engine in a way. You're losing mass as you're gaining your velocity by accelerating your mass. And so the formula has to keep changing every millisecond of the action happening because you don't have a consistent mass. That kind of problem. Anyway, that's more said than I wanted to say on that. All right. So he says here, Yapiro just answered the 3 questions. He didn't get to any of it. So didn't answer any of the questions. Well, he did answer one of them, just overtly insanely, in the sense that he said something that is just can't be true, that they have the same kinetic energy, when clearly the 10-ton train going 5 miles an hour can't have the same kinetic energy as the 5-ton train going 10 miles an hour, 10-ton train going 5 miles an hour. All right, anyway. All right, so I read that, and I read that. So, yeah, that's enough of that. All right, so we'll go to this guy. So now we'll do a little bit of physics. All right. So this first statement, see, this is why comments just aren't too useful. He's got a whole bunch of subjects, and he's glancing at them. He's not, getting into anything called physics here. So this whole first statement is just so useless. Your muscles are responsible for all action. It doesn't even say anything. How do my muscles do that? Blah, 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 blah. So they push through the Coke bottle, whatever that. They don't push through it. So that's stupid. And they fight to create that impulse to the Coke bottle. Blah, 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 blah. That doesn't mean anything either. If you knew how muscles work, you would see a lot of little pull backs in them, which amount to push forwards for the bottle. Well, if you look at the heart muscle, for example, you'd see that it's just creating ions. Okay, so it positive ions, then it switches to negative ions, then it switches to positive, and then it switches to negative. Okay, so we're basically talking about electrons going in, electrons going out, electrons going in, electrons going out. Clearly equal and opposite reaction is kind of obvious. But anyway, if you knew how muscles work, then you see the little pullbacks in them, which amount to push forward for the bottle. So again, you're not getting to the essence of it. Okay, I'm arguing that what we know. So this is one subject. Okay, so I brought this subject up before, but clearly the physical evidence from the universe says electrons and protons, right? I can't shoot them. So even though they say an electron gun, it doesn't shoot very far. Okay, the electrons lose momentum. They are dragged to a halt by the universe. So there is actually some force that you must account for, some ether, some stuff that electrons can't perpetually move through. So the fact is electrons and protons, you can't make like a laser beam that goes to the moon. You can't shoot them anywhere because they lose their momentum to the universe. The universe drags it out of them because they're moving into the field of force. So they're hitting more of it in this direction. There's more force. They're hitting more stuff to hit in this direction than obviously in that direction. Okay, there's more stuff coming right for it, okay, opposing it, than there is stuff catching up to it from behind and hitting it, because it's moving away from this stuff and it's moving towards this stuff. So it's obviously going to hit more of that stuff. So anyway, drag is a real subject, a real issue for the elemental bits. Now, when we get to the helium nucleus, and it doesn't matter how I draw it, but let's just say we get to a configuration where we have electrons and protons in an arrangement. This arrangement is capable of meeting the drag, okay, by essentially when it hits more force, it gets stronger. So when it hits more force, the electron and proton end up getting closer, and there ends up being more pressure bouncing between here and here between these two electrons, which means it's meeting the force this way with more force this way. So it's able to create an engine against obstacles. So it's like having a little a mechanism where if you put it in a stream, okay, because of the way the arrangement of your little pieces, the more the river fights, the more the river pushes you, the more you're capable of pushing back. The more elastic you are, and inelastic in the sense that more you create a condition that now creates more in this direction, more force to fight this force with. So it's as simple as me making this argument about ping pong balls. You know, if I have a ping pong ball bouncing at a constant speed between my two hands, right, and I move my hands twice as close together, the ball will hit my hands twice as often, creating twice as much theoretical pressure. You're saying I didn't do anything but move them closer together. I didn't add more energy. I didn't do anything but move them closer together. And I made more energy. More energetic events take place. And that's what matter relies on. So the nucleus of the atoms decides the direction of the atom. That's the, if you want to say something contains the momentum of the atom, that's where the momentum is stored, is in the helium nuclei that make up the nuclei of all material objects. All material objects can be described as how many helium nucleuses are in the nucleus. You can just count the helium nucleuses and you can count, you know, and acquire an atomic number. And they're deciding which way something's going. They're deciding its bias, you know, directional bias. because it's going to depend on which way those little motors are pointed. So anyway, so all you're doing when you're hitting something is you're using the interaction is pushing these electrons in different directions, which are going to change the direction of those nuclei and line them up almost like magnetic domains. If you can line up all your nuclei, all the nucleuses in your atoms can be lined up in the are pointing in the same direction, then you can magnify your velocity in that direction. Where, because you're not doing the other stuff anymore, you're not doing the noise stuff, you're making signal now, and now they'll go in a direction, and that's really all the transfer is doing. So when you hit one thing into another thing, you're taking these little guys are all pointing in a direction. When they hit the surface, that direction goes into this new surface, and it reorients all of these atoms with the vectors that it's getting hit with. It's getting hit by a bunch of vectors from this other place. Those vectors are just pushing it through here. Now this relates to another comment this guy makes, so I'll get to that before I go into a more complex explanation. Let's see, so this too I don't think is relevant. Kinetic energy formula holds between defined quantities. It doesn't hold anywhere, so you can't show me any physical evidence of it holding anywhere. Anyway, defined quantities not in reality. So that doesn't even make any sense. The defined quantities that aren't real. I mean, what is that? I'm just saying this is just gibberish, you know. So what I'm saying is simply that change of impulse across some length past amount of gained energy. So it's more of this crap about velocities and distances and all this shit. It has nothing to do with any of that crap, frankly. All right. And mathematically, that shit holds. It doesn't hold anything. Impulse is mass, velocity, length is velocity, time, energy is 1/2 mass, velocity, velocity. Says you. In another comment, he doesn't agree. He doesn't think the kinetic energy formula is real. So I don't know why he's doing this shit. Well, anyway, this was just gibberish, so forget that comment. Those two objects will compress the identical spring differently. So where did you defend this assertion? That's one of the things at issue here. So you're saying, unlike what people think, springs aren't consistent. So if I use magnets, you know, maybe that's more reliable, right? Because I think all of the formulas for magnets don't care about how fast the two magnets go into each other. It just depends on your position. So, you know, it's just not going to matter. You're not going to go further because you're going faster. So the two magnets repel each other. How come these two aren't repelling each other? They're attracting. Oh, it's because they're so small I can't hold them in the right position, I guess. Yeah, so they're repelling each other. So when I push into that force, it doesn't matter whether I push in slow or I push in really fast, I'm going to get to the same location. Either way. That's all we're talking about. You're saying that doesn't happen with springs. I'm saying I haven't seen any evidence it doesn't happen with springs, so until you show me a piece of evidence, that's just a statement. Alright, springs will react at first the same way since their impulses are the same, so that doesn't make any sense either. But then the spring inflicts harder and lighter ball, Newton's law. So what does this have to do with Newton? Nothing. Also, the lighter ball has larger velocity. Also, the lighter ball has larger velocity. Yes, we've already been over that. Inverted ones are the best way to do it. So you need to draw to see how fast you can speed change for the lighter ball compared with the other slower ball. Whatever. So again, just the first premise is the one. What? You says you. These two objects will compress the identical spring differently. What two objects? And if they have the same momentum, no, they won't. Similar questions. Simple definitions of acceleration is this s, v, whatever. As fast as train has half the mass. The faster train has half the mass. So by Newton's law again, the lighter train has double the acceleration. Well, again, this isn't about acceleration. This is about velocity. It doesn't transfer acceleration. It transfers a velocity. So just more bullshit. All right, V is double, A is double, so S is double in this equation. In what equation? If the train goes the farthest, it did more work. So just, this is another huge misunderstanding. So, okay, this is a good subject, though. So, I mean, I've been over it before, but I mean, this is important to understand that all of these exchanges could be like a 2-pound bowling ball could knock down, theoretically, an infinite number of pins. Okay, I'm going to have to wait for that to dry, unfortunately. I mean, a 2-pound bowling ball theoretically has as much energy as a 5 million-ton bowling ball if all we're going to say is how long can I keep the energy moving in one direction. So if I line up all the pins perfectly and the pins never create any directional deviation, I can have the energy go for a very long time because the only energy I'm losing is the contact energy. So if we get rid of that friction, you know, we put perfect springs between the pins and do other things, the energy goes forever. So this doesn't have anything to do with distance. Distance isn't how you measure energy. You measure the energy by collecting it with some counterforce, some known counterforce. That's why gravity is fairly good, is because you can throw something into gravity and gravity always counterforces the same. It always does it consistently. Okay, and in gravity, how long you're in the gravity is what's going to matter. How much time are you in the gravity? That tells you how much gravity affected you. Not how much distance you traveled, how much time you're in the rain decides how much rain falls in your bucket. So it doesn't matter whether your bucket's moving. It just matters how long you're in the rain. That's the part that matters. And yes, if you're moving exceedingly fast, then obviously it could matter that you're in a different amount of gravity. But for the sake of argument, under normal material speeds, okay, it just can't matter how fast you move through the gravity, because the speed has nothing to do with how much rain is falling. Now obviously if you start traveling huge amounts of distance in a very short amount of time, then you're going to be in a different amount of rain. Okay, the rain diminishes as you go higher. But for all of these experiments with things going under, 3 million meters per second, there's not going to be any you escaped the gravity because you went so damn fast problem. Right. So it's all about how you collect energy, and the point I've tried to emphasize is that momentum is a volume. Okay, so your mass is the platform, and the velocity is the other component. So these two objects have the same momentum. They have the same volume. Okay, so I can't use a V because that's too much like. So their V and their M numbers, okay, are just the square created, the volume. So you take their mass and their velocity and you can understand the volume. So this is the energy. So yeah, we could just call that the energy. So the energy is the mass times the volume. That gives you the amount of quanta, the quantizable hunks of energy. That's how many hunks of energy it has. Okay, so if it's a very few pieces of matter I hit with a force, the same amount of force, the same volume of force. So I take a volume of force and I hit two things, right? The volume can spread over the tiny amount of mass and they all get high velocity, or it can spread over a lot of mass and give them low velocity. And so when you're doing a transfer between two objects, sorry, should have enlarged your view. Okay, so you're doing a transfer. What you could do, theoretically, again, the only thing that's going to change is you have a certain number of these little bits of energy with a little vector, okay? So they're just vectors of energy, and I would argue the force is actually moving the speed of light, so they're all moving the same speed, they're just moving in different directions. And all you're saying is when this object is going 2 miles an hour or whatever, it has an extra amount going in this direction than it has in this direction. So it has less, going one way, and more going the other way relative to everything else. Okay, it's absolute condition. We can't know because we don't live in the absolute universe. We live in a universe of atmosphere and stuff, other stuff moving with us through space. But anyway, and so what's going to be transferred is that bias. So the thing you hit has a condition. Now, we say not moving is the normal condition, but obviously it's moving through space at some vector. So we're just saying that for the purpose of observationally, this one appears to be 0. It doesn't have any bias. It has the same amount of stuff going this way in it as going in that way. I hit it with something that does have a bias, okay, that does have more stuff going this way. What's being transferred is this one hits this one, and this force is still going this way. So the force goes right into this object and then ends up reflecting back and forth in here, okay, like the electron motor, okay, the reflections going back and forth against the proton. It's reflecting back and forth, but it always is going on. This direction was the first direction, so that was plus. And then this direction stops it. Then it goes to 0. Then it goes plus again, and then it goes to 0, and then it goes plus again, and then it goes to 0. So I've made these videos pointing out that that's the real way things move through the universe, is they're really going, then they stop. They don't go in the opposite direction. They stop. Then they go again, and then they stop, and then they go again, and then they stop. Like if you make this ideal cart in space, and I throw something in the ideal cart, and the thing hits the surface and makes it move forward, right? Yeah, and then it reflects, okay, because it bends the surface out, the surface pushes back to straight again. That's the reflection. It reflects back to this wall. Now it hits this wall. When it hits this wall, it doesn't go backwards. It stops this forward motion. So the forward motion continues while it's going, and then the little thing in space is traveling this way. The cart's still going this way. The cart's still going that way, while this is traveling this way. Then it hits the back wall. This is the same thing. Dimples it, and the dimple pushes back. Okay, so now it stops, and then the dimple pushes back, pushes this forward. It's still stopped until this hits the front wall. When this hits the front wall, it goes forward again. So it's going forward, stopping, forward, stopping. All right, now we can relate this to his other comment. See, this is where it's just, too many subjects built into one. All right. So we will go to similar questions. Simple definitions: acceleration faster than half the mass. So Newton's second law: the lighter train has double the acceleration. Okay, that's just horseshit. Hardly close to 100%, but not in favor. So he's not even, he's responding to things he's not quoting, which is just too stupid, because whatever you use to collect the transfer will lose its good properties over time. That doesn't even make any sense. All right, so the other comment, this must be the one that is the one that's useful. You are making explanation which is not easiest one. So he obviously doesn't speak English either. Why does pushing the exhaust makes you go opposite? The exhaust was going in circles, hitting back and forth. So it doesn't hit back and forth. So that's the part you have wrong right there. Always changing the direction of its pushing. Okay. But if you saw it go out the right, that means the last moment before leaving, it bounced something to go forward, right? It means that obviously what's happening is what I've just pointed out. So I'll do the rocket engine thing one more time. I mean the pressure part, not the explosion part, the pressure part. All right. Yeah. Well, I'm going to have to wait for this to dry again. All right. Well, that's the liability of having it wetter than it needs to be. Well, maybe take a short break, and then I will continue. Yeah. Ooh. Yeah, still not quite good enough. I'll be back. All right, close enough. Anyway, so I was explaining. All right, so you have any vessel there is, anything, any whatever. The idea is there's a little stuff in it. So if we made it just one thing, one little bit, you could see the one little bit bounces here, bounces here, bounces here, bounces here, bounces here, bounces here, bounces here. So if I could make it go trillions and trillions of interactions per second, you would understand that the same amount of pressure is hitting this wall, is hitting this wall, is hitting this wall, is hitting this wall. So the catch is that if you count each one as a plus, okay, you could sort of understand that if the last thing the thing does, so what we're saying is we're going to open a little hole and let it out, okay, so it's going to fall out this way. Obviously this way, the last act was probably this way, okay, so the act right before it was something had to have hit this way to reflect this way. So we've eliminated what would have compensated, like a circle. We've taken part of the action is this direction, part of the action is this direction. If I eliminate one of these, then I have an extra one of these, okay, and that's what I'm stuck with. So I'm stuck with this as the last act, and there's no compensating. So this is the yin, there is no yang, because I let yang go out. So the thing that would have stopped the box from moving this way, which was hitting the bottom of the box, that would have stopped it from going that way. That didn't happen now. So the box is going to keep going that way, because just like the bucket, it's like, you know, the thing went in, and if I eliminate this wall, then this thing goes out, and there's nothing but this. There's no stop. There's just keep going. So the same thing is happening. So if we make millions and billions of these little things bouncing around in here, you're just saying that if I'm letting a bunch of them out this way, the last act was this way, which means the object is going this way because I am eliminating the counterbalancing bounce inside the box. The box isn't going to get this down to push it down because I'm letting all the down stuff out. All it has is the extra up stuff. The plus here, the plus here, the plus here, and there was never a minus, 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 so that none of these pluses got wiped out. So all of these pluses are all forward directions, and so it keeps going in this direction because there's no this direction to counterbalance. So I gave away this, and by giving this away, that's still alive. It's not counterbalanced anymore. My mass didn't get this, it only got that part. It got this part, it got the yin, didn't get any yang, therefore it goes yin. So that's the part of the pressure. So that's how a fire extinguisher can give you acceleration. That's obviously not the whole story for a rocket engine, which is first I do the pressure thing, then I ignite this shit by combining atoms, which means the atoms all get big. They go from being little atoms to being big giant atoms, taking up more empty space inside of the atom, expanding, and by expanding, okay, they're pushing against each other, creating all kinds of velocities, and those velocities ends up going this way because I have a cone here that's deflecting it, and I'm ensuring that I'm taking as much of that expansion as possible and sending it this way, creating this action is a hit, this action is no hit. That's what I'm doing. I keep trying to make this not hit anything, and I'm trying to make this hit as much as possible. So the stuff I'm trying, so I'm trying to get as many hits as possible this way, and as few hits as possible for the stuff going this way. And so all the deflected stuff is the tricky bits. But anyway, that's why the nozzle is shaped the way it is, because it's basically saying, hit me, give me a portion of velocity in this direction, and I will use that portion. Yeah, that's probably enough. All right, so at the moment we're stuck with essential experiment. The essential experiment, I say I've already created a logical conundrum in the sense that the experiments that exist, the ones I've shown, show that a spring does conserve the momentum. The physicists all say it does. Okay, so they all say that a spring conserves momentum. They all think so. And the experiment that indicates it is you put these two carts. You either pull them apart and let them swing back into each other, or you compress a spring and let them shoot off. And the fact is that it always gives the same energy to both sides. So whether it's a brick wall or a feather, the same amount of energy is going this way as is going that way. And this car is always going to leave with the same momentum. unless you can move the center of gravity of the spring. So that's the only part that gets a little bit tricky, is when you get very, very light. Then the spring can't give more velocity to the lighter object. The spring can only move at a certain speed. It can't give its momentum to something if it can't move that thing at the same speed the spring is moving. So if that thing needs to move faster than the spring can move, then you won't transfer the momentum to the lighter object. So we're just so stuck until we can establish what a correct way to measure energy is. And my whole argument is the key to measuring is preventing the energy from creating heat and other things. Because if you create those things, you're not measuring the heat. You're not measuring the momentum in the direction. You're measuring, now you're creating other directions, and those other directions aren't going to be conserving the momentum. So when they say conserve momentum, or momentum is conserved, obviously if something creates sound or deformation or heat, that is the momentum being conserved. The momentum is being converted into heat. That is, if I turn the grinder for the cutter for cutting a cannon or something, and everything's getting very, very hot, well, that's because I'm not cutting. Okay, so the less effectively I cut, the more likely I'm creating heat. The more energy I'll lose as heat. I have the same work I'm doing, I'm just not getting anywhere. Well, that's, it's getting hot because I'm being less and less efficient at doing the cutting. So the momentum is clearly converted into eventually heat. And the whole idea is to try to keep it going in one direction. So if I can line up all the bowling pins, and I can reduce the amount of vibrations in the floor and the walls and all the other places the energy would have gone if I let the pins scatter any direction. If I force them to move in one direction, I can maintain the energy for a very long time. I can knock down 1,000,000 pins, theoretically, okay, with a 2-pound bowling ball. Okay, if I arrange the collector in such a way as that it keeps maintaining the energy in the right direction. So the key is high velocity objects tend to push the energy in the same direction they're moving. So this is another one of these important things that I've said thousands of times now, right? I mean, is it actually 1,000 times? I don't know. It might be pretty close. But we'll do it one more time, just to be inclusive. Now, this might not be in, my kinetic energy video, the 15-minute video, but you can't put everything in, a video. So, but it's an important reason why to understand that fast things don't have more energy. They're just more likely not to create friction and heat. They overwhelm friction. They overwhelm the substance in such a way as they defeat the friction, the capacity for the misdirection, the scatter. They eliminate scatter. So the faster you can make something go, the less scattered its energy is. And the slower it's going, the more likely the energy is going to scatter in different directions. Is probably a good way to understand it. You can sort of get somewhere with that anyway. All right, so the simple premise. Yeah, turn it back on. Had to make sure it's still on. So fast things, okay, things going fast versus things going slow. So the trick is when you're hitting the little bits of the something, all right, the faster you can hit them, the more likely the electrons move in the same direction that you're going. So the faster the impulse, the more the vector, the less the vector in this. So say if this electron was moving this way. So this individual electron's going this way, and I hit it with my vector. If my vector is very long, then the composite vector is going to still be very much in my direction. But if my velocity is slow compared to the electron, then I'm going to have a vector. My vector is going to be this way, the electron's vector is going to be this way, and the outcome is going to be, this. So I'm not going to, so the more the electron's going faster than I am, the more the bias is in this wrong direction. So now the energy is going that way instead of this way. So if I push things fast enough, I can keep the energy moving this way. It's sort of how sound works, actually. Sonic booms work on the same thing. It's the speed that makes it possible to keep the atoms moving, vibrating in the same direction. Push, 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 and they keep going in the same direction because you achieved a velocity fast enough to keep the energy moving in that direction. So the ray of sound, okay, has more power, okay, the faster I can make the ray go. The faster the ray, the faster the impulse, the more the ray stays in this direction, because every atom it hits going forward, it keeps the energy going in the same direction it's going. So it means that when I hit this atom, I gave it my energy, but it's still doing work in the same direction I'm doing work. So it's plowing the road for me. I've used these words. That's why the velocity makes it more effective. If I go slow, I plow snow in all kinds of directions because things go off in all kinds of directions. If I go fast, I make everything I hit ends up being a plow on my side. My team wins. I get a free ride. I don't have to hit this one because this one hit it for me. I don't have to hit this one because that one hit it for me. So this ends up going straight through without hitting anything because all of these are hitting it for it, if you get me. So the momentum is staying in the direction. So velocity gives you the illusion of more energy because it more efficiently plows through things, but it isn't really more energy. There won't be more little bits of stuff flying in the universe. You will not create more motion in the universe with a fast thing than a slow thing. The total motion will be equal, okay, between the 10-ton train going 5 miles an hour and the 5-ton train going 10 miles an hour, okay? The amount of stuff, atoms, molecules, electrons, protons, photons, moving in the universe, these two objects will move the same amount of mass in the universe. They will cause the same amount of total things moving in a new direction. That's the logical premise. I believe it because it makes perfect sense. I don't believe it because I'm perpetrating some doopy fraud on people. I don't believe it because, you know, I don't know, somebody paid me to do it. I don't believe it because somebody put it in my brain when I was 5 years old or something and programmed me like a Russian conspiracy or something. They're going to make a phone call and I'll blah, blah, blah. No, I believe it because it makes sense. And this is how Newton saw the universe. This is what he saw happen. He saw momentum, velocity times mass, a volume of stuff being transferred to other objects. A condition being transferred. Blueness, redness, yellowness, transferred from one thing to the other. I can just attempt to reason. There's nothing else I can do. You're unreasonable, you're unreasonable. So the irony is that Stephen Bro has written some comment ragging on this guy, calling him some sort of also conspiring against them, lying and cheating and being a terrible human being. So he's just proving how incredible his theories are. He has these silly theories. They're absolute nonsense. He doesn't have any evidence for them, and yet he'll pontificate on and on and on, in his delusions. He's a delusional kook. I think it should be obvious to anybody watching this video, I don't know who this guy is. He could be Farley for all we know, okay? Yeah, who knows who he is? And clearly all he's done is say, some of these questions seemed interesting to me. I'm going to see if we can get actual answers. And this is being somehow defined as an attack. He's taken a side in the sense that he says, well, those are interesting questions. He isn't dismissing the questions as uninteresting. So he's just saying, show me. And this apparently isn't a respectable action on his part. Asking to be shown or have something explained is an offense to these people, clearly. All right. It's certainly a challenge, and yes, it is a challenge. There's no doubt about it. He is challenging you to justify and defend, and they don't want to have anything to do with justifying and defending. Okay, so anyway. So, to JPG, I would just say, what would you do with this comment? It's all over the place. You know, some parts are incoherent, some parts are blah, blah, blah. You're saying it's, helps the continuity of my videos to keep comments that are going all over the place. I'm saying it doesn't. Yeah, that's what I'm clearly saying. So anyway, we'll have to agree or to disagree on that one. And but for now, I'll leave that slop up, and we'll see where we go. All right. So enough of the video. So till the next time and such. So again, we have to discuss evidence, and just unfortunately, I think that the way to go is what all of the haters should do. Is they should just put that hate away for a little bit, and let's all sign a petition or something, an email. Let's all sign the email and send it to MIT or one of the institutions and just say, could you please do these experiments that would make it clear that you're not talking crap? Could you clearly just make a really good, let's prove kinetic energy experiment? So could you do this thing with the different weights in the air? Could you do these experiments, please? Because that's all until we have hard evidence, we don't have anything to really argue about. You're just making assertions to me, and you're saying I should believe it because you say so. And I've already pointed out how your math is just convoluted. You've just created Frankenstein monsters to fall in love with Frankenstein monsters and then say, see, Frankenstein is lovable. No. Okay? No. It doesn't work. It's such a canard. Okay, that this and again, the whole lie that somehow mv squared is the derivative of Newton's mechanics, when it's absolutely an attack against Newton's mechanics. It's an attack against momentum, and momentum was everything to Descartes and was everything to Newton. The whole universe became understandable through momentum, and mv squared is an overt attack against that simple understanding. All right. So, till the next time and such, and so forth and whatnot.